I actually built my own rate limiter from scratch using Node.js. And this is a very interesting mini project that you should know, because rate limiting, of course, is a very important concept when you actually build production grade applications at scale. So first, let's understand what a rate limiter is. So basically, if you have any API service, which users call a lot of times within a certain time frame, then what happens is you want to rate limit those APIs. For example, if there is a certain API which does a heavy computation or something, then constantly calling that API or performing that calculation over and over again can become a heavy task. So in that case, what you want to do is you want to rate limit your API, which means you are telling the API that if a particular user from their own IP address is trying to hit this API more than a certain threshold within a given time frame, then make sure that once the user calls this API this many times, let's say more than 5 times within 10 seconds, then the next time the user hits the API, rate limit it, in the sense that don't give them a response. Because you don't want a user to keep hitting the API a lot many times within a few seconds, because that can cause your server to take a lot of load. So for example, let's say there's a malicious user who creates an endless loop to call your API. So in these cases, you can ensure that this specific API should have a threshold that if it's called, let's say, more than 10 times within 20 seconds, then the 11th time it's called, it should not return a response, or it should return some other response rather than computing the heavy task. So that's what rate limiting is. So I have created an example over here. It's in my local setup. So right now you can see it says, okay, true, message hello world. But if I refresh this continuously a lot many times, you'll see what happens. Let's say if I refresh, there you go. I refreshed it a lot many times, and then now I get an error saying too many requests, and you can see the API has failed. So if the user tries to refresh this or call this API a lot many times, then you can rate limit it by ensuring that your API doesn't perform that heavy computation and it doesn't let the user access the information for a while. So this is also seen in many APIs provided by LLMs, for example, Gemini, ChatGPT and all. So they don't want you to constantly call their APIs a lot many times because it can incur heavy costs. So they also rate limit their APIs. So now, to the implementation of this. Now, before I start with the implementation of this, there is something called, there's a particular algorithm I used to create this rate limiting functionality, and that is nothing but the token bucket algorithm. So if I go to Excalibur over here, you can see I've created a small diagram explaining that algorithm. Now over here you can see there's an incoming request, and here you can see there are some variables. So before I dive into this algorithm, just know that, just imagine some sort of a bucket where you store tokens. Okay, it can be a map or an object or anything. You can consider it as a map, and in that map you store the number of tokens a user has. So basically, let's say in a bucket, if I have 10 tokens, then that means the user can make 10 requests without getting rate limited. But let's say if the user keeps on requesting that same API, then per request the tokens from the bucket keep getting removed, and as soon as the bucket has 0 tokens, the user won't be able to make any request until a specific time limit has been crossed. So basically, to decide after how much time limit the next tokens should be added to the bucket so that the user can make the next requests, we store some variables over here. So just know that an incoming request comes from the user, then the server checks are there any tokens in the bucket. If there are tokens, then consume 1 token. So basically, let's say if there are 10 tokens, user can make 10 requests without getting rate limited. If there are tokens in the bucket, consume 1 token. So 10 minus 1 will become 9. Forward the request to the server, basically perform the computation, and then request process successfully. So the user can keep hitting that API. It will keep consuming 1 token, 10, 9, 8, 7, and so on, until it goes down to 0. When the next incoming request comes, are there tokens in the bucket? No. So reject the request or delay it, and you can basically block or queue the request. So that's token bucket algorithm. Pretty simple. Alright, now the only main part over here is to ensure or to know at what rate you want to fill the bucket with tokens. Again, let's say the user consumed 2 tokens out of 10. That doesn't mean you will fill the next token after all the 8 tokens have been consumed. No, you will fill the next token, basically the 9th token, again after a certain time limit. You don't have to wait for all the tokens to be completed to be removed from the bucket for the next token to be filled. Every time after that certain threshold is reached, that certain elapsed time has been crossed, the token should be added to the bucket until the max bucket size. So once the tokens being added to the bucket cross the max bucket size, we will always ensure that the tokens take the max bucket size. So if there are if the max bucket size is 10, and after every threshold, the tokens keep getting added, and let's say we cross from 10 to 11 or 12 tokens, then we'll make sure that the bucket has 10 tokens instead of 11 or 12. So there's going to be a max limit to the number of tokens a bucket can have. And every time a token is consumed, let's say from 10, we hit 5 requests, we have 5 tokens. It doesn't mean that after 5 remaining tokens are removed, we are going to refill the tokens. No. After a certain elapsed time, we are going to keep refilling the bucket with tokens until the max bucket size. Okay. So you can see over here, refill tokens at a fixed rate. So every time we refresh, so every time we call the API, we will check if we need to refill tokens or not, depending on the elapsed time, which we will decide the threshold of. So if bucket full, extra tokens should be discarded. The bucket capacity should be the max tokens. That's it. So the max tokens is going to be the bucket capacity. Okay. So now let's go ahead and see the implementation. I have actually already implemented this. If I go to my code over here, I'll go to my server.js first. So this is pretty self-explanatory. I have this Express server setup. I'm just initializing Express. And over here, I'm using app.use and I'm calling the token bucket rate limiter. So in the app.use itself, I am calling the token bucket rate limiter, which ensures that for any of the APIs that we hit, we first are going to call the token bucket rate limiter. If this function tells us that we can go next, only then we will go to these APIs. If this function says we can't go next based on its rate limiting logic, then we won't be hitting these APIs. All right. So this is nothing but the API /hello. And it returns okay true hello world, which is nothing but this over here. If I refresh this, you can see it returns okay true message hello world. And here we are just listening to the port, so we can start our server. So now the main part is the token bucket rate limiter. So you can see over here we are sending 3 things: the tokens per interval, the interval in milliseconds, and the bucket size. So basically we are saying the bucket size is going to be 10. It can hold 10 tokens at max, and then the tokens per interval. So in every 10 milliseconds, 5 tokens should be added. So basically refill 5 tokens every 10 seconds. And the bucket can hold up to 10 tokens. So that means per second, we are adding 0.5 tokens. And if you convert that to milliseconds, it will be per millisecond, we are adding 0.0005 tokens. All right. So if per second we are adding 0.5 tokens, that means every 2 seconds we add a single token. So that is our refill rate, that every 2 seconds we add 1 token. But we need to convert this to milliseconds, so we'll check that later, don't worry. Now I'll go to my rate limiter.js. Here we have our token bucket rate limiter. This is nothing but the object which has these values, which defines the rate at which we need to fill the bucket with our tokens. So here we destructure these 3 values: token per interval, interval ms, and bucket size. This is actually not there, not being sent from here, the key generator, but we are just creating it over here itself. You can create this outside of this part here. You can create it here as well. We'll just let it be there. So the key generator is nothing but it checks the IP of the request. So let's say I'm trying to hit that particular API, then for my IP, it will rate limit it. But let's say another IP hits it, then its token count will start from the scratch. So this is going to uniquely identify each request based on the IP. So for example, if I am hitting it and I have lost all my tokens, then it doesn't mean that if any other user hits this API, they are not going to see the response. They are going to see the response because their tokens haven't been expired. So we are going to use the key generator based on the IP to differentiate between users. So then we create a bucket, which is a map. This holds per client's bucket in memory. So based on the IP, we can create each user information based on when they last refilled their token, how many tokens they have remaining, and so on. So based on their IP, we are going to create structures in the map that hold the different IP information of the users. So for each user, we are going to have values like how many tokens they have remaining, when did they last refill, and so on based on their IP. Then after that, there is pre-compute refill rate in tokens per millisecond. So this is nothing but the refill rate. Like, as I said, we don't refill the token in the bucket once all the tokens have expired. We keep refilling the tokens until the bucket size has reached based on the refill rate. So let's say 6 tokens have been used. We have 4 tokens remaining. That doesn't mean we're going to add the next token only when all the 4 tokens have been removed. We can keep adding the tokens until the max bucket size, until every time the refill rate has been crossed. So what's the refill rate? The refill rate is nothing but tokens per interval divided by interval in milliseconds. So the tokens per interval was nothing but 5, and the interval in milliseconds was nothing but 10,000. So that means you have 5 divided by 10,000, which is nothing but, as you can see, 0.0005. So the refill rate is 0.0005. This is in milliseconds. Just know that. It's not in seconds, it's in milliseconds. So basically every second, 0.5 tokens are going to be filled. So every 2 seconds, we add 1 token. So then over here, I'm just returning this function where I am performing the main logic. So first I'm extracting the key, which is going to contain which is calling the key generator for the request. So it's going to contain the IP and all that information. It's going to differentiate the users. Then I'm taking the date.now. Then in the bucket, I am either getting the existing bucket or initializing a new one. Let's say I'm making the request a second time. Then in that case, I need to get the existing bucket that already exists. But if I'm making a request to that API, the API/hello for the first time, then I just need to initialize a new bucket where I store the tokens, which is obviously going to be the bucket size. If I'm hitting the API for the first time, for that user's IP, the tokens will be the bucket size, which is 10, and the last refill is going to be now. Okay, because that's my first request. So it's been refilled now, and the token is the bucket size. Then for each request, I need to check whether I need to refill the tokens or not. So refill tokens based on time elapsed since last refill. So the first time I click this API, I hit this API, the last refill is now. So the now minus bucket.last refill will be 0, so we won't be refilling anything. But the next time I hit this API, I'm going to get my bucket from buckets.getKey, which is going to have that token and last refill value. And then we are going to check that what's the elapsed time. So what is the time now when I hit that API again minus the bucket.last refill time. So it's pretty self-explanatory that to know how many tokens I need to refill, I need to calculate the elapsed time multiplied by the tokens per millisecond that we are allowed to add in the bucket. So the tokens per millisecond is this. The tokens per millisecond we can add to the bucket is the tokens per interval divided by the interval in millisecond. So the tokens per interval, as we said, it's 5. We can refill 5 tokens every 10 seconds. And if we convert all of this to milliseconds, then we add 0.0005 tokens per millisecond. So the tokens per millisecond into the elapsed time, this gives us the number of tokens we need to add, the extra tokens we need to add for the elapsed milliseconds. So our new bucket.tokens will be the math.min of bucket.size and the already existing tokens plus the refill value. So we are basically refilling tokens based on time elapsed since last refill. So we already have the elapsed time since we last filled the bucket with the token. So that elapsed time into the tokens per millisecond, the tokens we are supposed to add per millisecond, is going to give us the number of tokens we need to add. So let's say if I keep refreshing this quickly, then the tokens per millisecond, then the elapsed time is not going to be much. But if I wait for some time and then I multiply it with 0.0005, then I'm going to get a value greater than 0.5 or 0.7, something like that. So it's going to be 1 or 1.5, something like that, which is going to round to 1. So I'm going to get a value for the refill. So basically, if you keep refreshing this all the time or continuously, this value won't increase much because the time elapsed won't be much as well. So the refill value would be something like 0.2, 0.3, which will round to 0. But the moment we wait a bit and click on this again, the elapsed time will be higher. So let's say the elapsed time is 5 seconds. Let's say the elapsed time is 5 seconds and the tokens per ms is 0.0005. So 0.0005 into 5, you get it as 0.0025, but this, our elapsed time is also in milliseconds, so this will be 5,000, so that's 2.5. But let's say if I multiply this with 1,000, this would be 0.5. With 2,000, it would be 1, and so on. So we need to wait a bit so that this refill has a value greater than a decimal point of 0, and it has 1 or 1.5 and 2 and so on, so that those tokens can be added. So once we refill, our new tokens for that specific bucket IP is going to be math.min of bucket size and the tokens that are already existing plus the refill amount. So whichever is the min, we take that, because let's say if this goes beyond 10, then we, as we said, we want the max token limit to be the bucket size. So if this goes beyond 10, then we need to keep the bucket.tokens as bucket size, which is going to be 10 itself. And then we update the bucket.lastRefill, which is going to be the now. Alright, so every time we hit the API, the bucket.lastRefill is going to be now. Then we just do a simple check. If bucket.tokens is greater than equal to 1, then we consume a token, and then we update our buckets with our updated value of the bucket for that respective IP. And then we over here go to next. So that means next means we can go from here to this. So it automatically goes to this part and it allows the request. Alright, and these are just some extra headers that I've added so that the user can know what all values are remaining. For example, you can see X rate limit remaining, how many tokens are remaining, X rate limit reset, how much more seconds until the bucket completely resets back to 10 tokens. So if I basically do nothing but refresh this and I check this request, you can see over here I have added these information: rate limit, which is 10 tokens, rate limit remaining 9 tokens, rate limit reset in 2 seconds. So I'll actually do one thing. I'll refresh this, let's say 3 times or 5 times. 1, 2, 3, 4, 5. Let's read this now. So the rate limit is always 10. That's the total rate limit. Rate limit remaining is 9. Rate limit will reset in 2 seconds. Then the next request, you can see the rate limit is 8. Rate limit reset in 4 seconds. Then the rate limit for the third one is 7. Then for the rate limit for the fourth one is 6. And then the rate limit remaining is 5 for the fifth request. So one more thing I'll try to do is let's say I'll click this 1, 2, 3 at quick successions. Then I'll wait a bit and then I'll click this again. So now let's see the values. So this will obviously be, we start from 10 tokens, we go to 9, then we go to 8, then we go to 7 because I clicked these 3 in quick successions. Now if I click on hello again, you can see our rate limit is 8 instead of 6. In the previous request it was 7, but now it went to 8 because I waited for a bit. Basically I waited for a while before doing the last request, right? So that means when I clicked on this request, our code went over here. Over here it saw that there is one token we can refill and it isn't equal to the bucket size now, so we add bucket.tokens plus refill. So 7 plus 1 becomes 8, because based on the elapsed time, maybe we could just refill one token. So if you wait a bit, your tokens keep getting added. It's not like you have to wait for your entire tokens to be removed from the bucket until you can add the next token. Alright, and just know that every time I make a request, I am just setting all these values, but when I do bucket.tokens minus 1, it's going to remove the token from the previous latest value, because I'm setting the bucket value over here. So up until here, this value that I've updated isn't reflected till here. This updated value gets added to the bucket after this. Just keep that in mind. Alright, so now just to give you a little more clarity, what I can do is I can actually log the bucket values. So I'll say this after bucket, and this will be, so right over here, this will be before. So you'll see something now. If I, let's say, refresh this fast, and now if I go to my console, you can see how it starts from here. 10, the before will be 10, then the before is 9.048, because I'm constantly hitting the API. So it keeps on reducing from 10, 9, 8, 7, and because I'm constantly doing it, so you can see between before and after, of course, there is one token minus 1 over here, because after every time we hit the API, we are trying to update the bucket with the tokens based on the elapsed time via the refill. But because we are hitting the API so fast, the refill is a very small number, like in decimals, so it's not getting increased by 1, and it's only decrementing over here. So you can see these values. The after values keep going down, before and after values keep going down. So every time I hit the API, let's say the token was 6, it becomes 5 after that. Then when I hit the API again, the value was 5 from the last value. Then it becomes 4, then 3, 2, and so on. And then once it hits 0, it sticks to 0 for a while because I still keep on continuously refreshing. So the elapsed time is very less, so the refill rate is very less, therefore the tokens get incremented very slightly by decimal numbers, so it doesn't go up till 1. If I take some time and I hit refresh, then this gets filled. So now it's been some time. If I refresh and I check this, the tokens will be filled completely, because the elapsed time was more than 20 seconds and we fill 0.5 tokens per second. So in every 2 seconds, 1 token. So in like 20 seconds, we fill all the 10 tokens. So that's pretty self-explanatory. If you read through this code, you will understand what's happening. It's not so hard. You just need to refill the tokens in the bucket based on the refill rate, and you need to subtract the tokens from the bucket every time the API is called. And even if you subtract the tokens from the bucket, you need to make sure that the next time the API is called, you refill it even if the bucket has tokens. So you keep refilling it based on the tokens refill rate. Alright? So here in the else, if token is 0, so if it's not greater than equal to 1, if it's 0, we just set the header, retry after 1 second, and we send error too many requests, as you have already seen. Alright? So that is how you implement your own rate limiter using the token bucket algorithm. You should obviously go through this on your own, write this code by yourself, read through it and go through it on your own. This is a very interesting concept, and it will also help you ensure that your APIs don't load up the server and you're not charged with a lot of money for your API calls. Alright, so with that, that's all for this video. If you found it insightful, then drop a like and subscribe for more.